This presentation, we are going to discuss number 7. It says, one day you saw an interesting video on YouTube. At 2 p.m., you shared the link to only 3 people. Then at 3 p.m., each of your friends, each of those 3 people, right, shared it to only 3 people. Then at 4 p.m., each of their friends shared it with only 3 people. So it looked like the message is going viral. If this pattern continues, then how many people receive this link by 1 a.m. the following day? So that's like a geometric progression. It's like exponential growth. Okay. So let's read the explanation. That's it. It says the number of people who receive the link follows a geometric progression with a common ratio of 3, because each time it's been multiplied by 3. It says number 1, determine the number of hours. The shares start at 2 p.m. and continue until 1 a.m. the next day. This means the sharing takes place over a total of 12 hours. Okay, so 12, 2 p.m. 2 p.m. is 1 hour, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's 11. And then 1 o'clock. So that's 12 hours. 2 p.m. means 3 people raised to the 1 have the link. And at 3 p.m., remember, each of those 3 people shared it to 3 people. So that's 3 times 3. That's 9 people. That's 3 squared. So then that 9, each of that 9, 3. So that's 9 times 3. That's 27. 3 to the power of 3. So you can see the pattern. So that's why the common ratio is 3. And because 27 divided by 9 is 3. 9 divided by 3 is 3. Okay. So the common ratio is 3. And you can see the power increasing. The exponent is increasing. That's an exponential growth, which is a geometric sequence. So to calculate the total number of recipients, the total number of people is the sum of the shares from each hour. This is the sum of a geometric series with 12 terms. So n is 12, where the first term is 3 and the common ratio is 3. Okay? Because you started with 3 shares, so the first term is 3. The formula for the sum of the geometric series, right, for the sum for geometric series is S sub n is equal to A times R to the n minus 1 over R minus 1. Okay, so it's A times that fraction, where A is the first term, R is the common ratio, and n is the number of terms. We've got A, which is 3, and we've got R, which is 3, and we've got n, which is 12. So it's a simple case of substituting into the formula. All where we have A, we put 3. All where we have R, we put 3. 3 raised to the 12 minus 1 over 3 minus 1. And verify that 3 raised to the 12 is 541,441. Subtract 1 over 3 minus 1 is 2. Divide by 2, you get 265,720, and you multiply by 3, that will give us 797,160 people. So by 1 a.m. the following day, a total of 797,160 people had received the link. I just want to point out that the sum formula for a geometric series can be written in a slightly different way. Let's take a look at it. So you can type in Google the sum formula for a geometric progression. Right, so you can come with a bracket. Okay, so the A now is outside of the bracket, and you have 2 different versions, 1 minus R to the n over 1 minus R. That's for when R is less than 1. Okay, to avoid negative numbers. 1 minus a number smaller than it will give us a positive number. And you have the other version, a open bracket r to the n minus 1 over r minus 1. So you can see the difference with 1 minus r and r minus 1. This one is more convenient when r is greater than 1. Again, it's to avoid the negative values when you have r being more than 1. However, anyone will give you the same answer. It's only the only reason, the only what will happen when if r is greater than 1 and you use the one above, you'll get a negative divided by a negative. And if r is smaller than 1 and you use the one below, you'll get a negative divided by a negative. But at the end of the day, you'll get the same answer. And it's very common to have a outside of a bracket in the numerator. So you can try using the a is 3, r is 3, and n is 12 with the other different versions of the sum formula for geometric series. You can do that.